Hello, and welcome back to our series where we're teaching you how to go from raw data to machine learning. Today, we wanted to focus on a very important data engineering concept called an ETL. So let's go over what an ETL is in this presentation. All right, so from a high level, this is kind of what people might see happen. We kind of take all of these different possible data sources, Salesforce, Workday, MySQL, scripts, etc. There's tons and tons of data sources out there. You use everything from APIs to just scraping, websites, etc., to pull that data. And then we do something called an ETL, and then put it into some sort of data warehouse. But what is this ETL, right? Like a lot of people might wonder, okay, what is an ETL? What's the purpose of it? And so here's what kind of an ETL stands for. So ETL stands for extract, transform, and load. Basically, the extract phase, you have a portion where you're extracting from things like application tables, like MySQL, or you're pulling data with APIs, again, like Salesforce or Workday, or you're scraping some public data sources. The scrape could be everything from web scraping to downloading government XML or Excel or CSV files, etc. They put up new data all the time. Transform can have a combination of meanings, but generally there's a combination of remodeling, deduplicating, denormalization, and kind of renormalization depending on how you are processing it, as well as kind of adding this concept we like to call slowly changing dimensions, which basically just help you keep track of data over time. And then the load phase is pretty straightforward, which it means you're loading it into some sort of production system where analysts and data scientists can use it. This could be everything from a data lake to a data warehouse to some sort of final data storage system. Now, in order to do all of that, you need some sort of tool. And there's really kind of three categories of tools that you can use. You can use what we call no-code/low-code tools. You can use code-based frameworks, or you can just completely custom code your ETL altogether. So no-code, low-code is kind of what it sounds like. These are often tools that involve some sort of drag and drop component. So, you're just literally dragging things like what we call sources and destinations. So your source could be something like Salesforce, MySQL, Oracle, etc. Your destination is some sort of data warehouse like Redshift, or you could even use, if you're using something a little more mundane like Postgres or MySQL, you could use that arguably to at least design a data warehouse, or you could, drop it into a very specific data warehouse like Redshift, BigQuery, etc., where it's, actual software developed to be a data warehouse versus just purely the design of a data warehouse. But yeah, so these, on top of that, these tools also offer what we call transforms typically. So this is often what you reference as deduplication, denormalization, etc. So each of them kind of work different. SSIS is probably one that a lot of people are familiar with because it's Microsoft, that's SQL Server Integration Services. You can, again, it's just drag and drop. Fivetran's a little bit newer. It's kind of interesting because it allows you to kind of schedule SQL or DBT transforms as well. And even then, there's a lot of parameters and options in there. So it's kind of an interesting mix. As far as it's not really drag and drop, it's like a little more GUI based, similar with like some other tools like Stitch, where there's less drag and drop that you will find in something like Informatica or SSIS. And this might be more GUI based and kind of setting up just specific parameters that they'll tell you to fill in. Code-based frameworks tend to be, I think, one of the more popular between data engineers, like strict data engineers that like programming, because it gives you a lot of the benefits of no-code, low-code, as well as custom code without being too restricted. So one of the negatives of a lot of no-code, low-code is there are limitations, right? Like you can only do whatever transforms or destinations or sources that they provide. That's all you're going to be able to do. So generally speaking, if you have a source that's new or, one of the no-code, low-code options doesn't have, like maybe there's an API for some new third party that doesn't exist as a connector or as a source or even a destination, again, you won't be able to work with it more than likely. But with a code-based framework, again, you just have to code something. You have to custom code it yourself, but it is an option. And so those tools like custom or code-based frameworks like Airflow or Luigi have things called typically operators or something similar where you can really just call and parameterize things. And it really manages a lot of the hard portions of ETLs. So we're going to talk about some of this later, but like error handling, logging, tracking dependencies, and things that actually are very complex are kind of taken care of in this code-based framework. And there's a lot of the heavy lifting that you will have to do yourself if you choose custom code. So custom code is exactly what it sounds like. It really could be any language you want, whether it's Python, PowerShell, Scala, Java, whatever you feel like, really, technically. It's just basically whatever you want to do. And then you're going to have to set up something probably with cron. You're going to have to develop your own metadatabase to track dependencies. And there's a lot of extra lifting involved in this option. And I think this is why most data engineers tend to fall in the middle. I think most of them like to program, so I think they're going to tend to like to program. But they don't want to have to program, again, all that other heavy lifting stuff, which is really just infrastructure. And we'll talk about some of those infrastructure components as we go on. But again, it's a lot of extra work for not a huge payoff. And you're already typically pretty bogged down as a data engineer. All right, so now let's kind of discuss what a general ETL looks like. And again, this is general. This is not verbatim exactly the way you should do it every time, but this is kind of a good way of thinking about it. So there's really kind of three general stages in an ETL process. You've got kind of this raw data stage, staging area, and then the production layer. So in the raw stage, generally what is recommended, at least personally, what I found is helpful, is again, you extract that data into typically some sort of raw file. And then from there, you load it into the raw tables without really doing any sort of data transformations. Maybe you clean up some dates, maybe do some limited cleaning, but overall, you want to limit what you're editing. The reason being that once you insert that data into the raw, and if you were to detect some sort of error in that raw layer, because you should do some sort of QA, I say QA is in production, but that's for specific reasons. In this case, you're just kind of doing some sanity checks type of QA where you're just making sure you've got data, you're making sure that data makes sense, etc. And if anything goes wrong, if you've got complex transforms in your raw insertion, that could be the problem, or it could be something in the application itself. And that just causes a whole bunch of debugging issues, and it makes it more difficult to maintain the raw portion of the system. But if a problem comes up in raw, and you haven't done any editing yet or transforms, then you kind of have a general idea that it's probably in the application layer. Again, it's just helpful. It's just one of those things that, like, as you're kind of going along, it might be a helpful little hint to, instead of, adding a bunch of complex logic in this raw layer, to wait and hold off and put it into the staging layer. All right, so in the staging layer, you basically take this raw data and you are going to do this business logic and standardization, denormalization, deduplication kind of stuff. So for example, and we're going to kind of talk about this later, deduplication is kind of this very common thing that you'll probably have to do, because oftentimes, as much as people think that, every time you click or every time you update, maybe it just updates a single row, sometimes depending on the system you're working with, it might track it as a completely new set of data or a new row of data. And this can start to create, a lot of extra data. And, if you use it incorrectly, or if you let your analysts use it incorrectly, they might be making the wrong assertions. Also, you might have to do some sort of remodeling, because this might be the portion where you start either denormalizing or setting it up more like a data warehouse, etc. Some people do that more between the production or between the stage and production layer. They might add that logic. I do think that, again, adds a little risk, just because, again, if you separate out too much logic, so if you've got logic in stage and production, and if something goes wrong in there when you start running your QA, it becomes a little more difficult to tell where that happened. So generally, the reason I kind of break it up into these three sections is just for maintenance. If something goes wrong, I kind of know where the problem should be, and it's probably in stage. So for production, as we kind of go over and we've done all this logic, we've got this stage data, really my personal goal is to have mostly just a bunch of QA checks in this level. And we'll talk about some of those QA checks later on, but that just kind of lets you know, okay, everything I've done in the staging, okay, let's QA it to make sure it makes sense. If we've done all these transforms, we could have messed up the data. We could have had a left join somewhere that was incorrect or something, or done something out of order on accident. Maybe you didn't put dependencies correctly. And now you've got a bunch of null data in some columns because you did, when you joined in, there was no data there to join, but it was a left join, so you just pulled it in, and now production's gone wrong. And basically production, the reason I kind of have put QA before production is production should be quote unquote perfect data, in the sense that now analysts can access this data. And if you were to let that data in there for even a day, you don't know what decisions are being made off that data. And so production should really be this quote unquote clean and pristine data set where you want to make sure that you can trust it. So that's why I kind of have a secondary QA. You'll do QA really throughout every time you touch your data. But it's really this last certification where you're doing a ton of unit tests kind of things, maybe some integration tests where you test from raw all the way to production, not just a bunch of the logic that you're adding in stage. And it's really important basically just to certify and check off that, yes, I trust this data and it's now going to production. And generally if a QA test fails, you kind of can then call out either to stop the ETL, or if it's some QA test that, maybe there aren't that many issues, maybe it's just a few nulls, like 3 nulls. And if you've deemed it okay, you might let it keep going. And that's up to you. It really depends row to row, column to column. All right, so now let's go and talk a little bit more in depth about what goes on in the staging layer. Because this is kind of the most complex possible layer that can go on, at least if you've, again, got a lot of your logic there. So there's a couple things that could happen. For example, a very common thing is sometimes you have to merge data. Depending on how the data is treated, sometimes you'll have multiple of the same IDs, and one way you have to treat it is you have to merge them. So the system basically works by correcting the previous data to, for example, in this case, correct a cost that should be $100 by negating the previous $50 or $150. So now you have to kind of merge those data sets to get the correct number. This is very common, I think, in medical data, because often with medical claims, if you've ever gotten something from a hospital, they'll like send you bills, you'll go back and forth. There might be adjudication between the insurance company and the healthcare company, and all of this kind of stuff. So there's this, there's this constant back and forth with trying to get the right quote unquote cost for the person. And how they manage it can be different. So this is one of the ways, merging data. So you might have to merge the same ID. The other is appending and / deduplicating data. So always kind of bringing in the most fresh version of that ID. In this case, you'll see on the right side with the 150 and the 100 highlighted, basically you're going to remove the 150 and only include the 100 row, so that secondary row. And so this is kind of appending or deduplicating. And again, it depends on how they've set up the system, and you need to understand that every third party or data provider does it differently, and you need to understand how they do it. This is one of the first questions I generally ask if I can figure it out when I'm working with clients. Another thing you might add in this layer is something we call slowly changing dimensions. And there's a lot of different ways to do this. We give them different categories. There's slowly changing dimension 1, 2, 3, 6, 4 and 5 as well, but 6 is kind of like all of the other 1, 2 plus 3, so that's why they call it 6 kind of. But basically it's just showing dimensions changing over time or data points changing over time. So for example, let's say we've got a table that represents the store or some sort of store, and in that we have store manager, and we want to keep track of who's in charge of that store during what period of time. So we have a start effective date and an end effective date essentially. Which basically, again, just kind of tells you, okay, we're starting ownership or management under James Smith in January, and then, in February, he left, he quit the company, whatever. It was a 1 month, it was a terrible month. And then Kelly Jones picks it up in February, and then it's null because essentially until there's an end date, there's no reason to fill that. And you can kind of use that as a flag. Like, in fact, some of the different forms of slowly changing dimensions will have an is active or most current type flag. In this case, you can also just use a null that kind of represents the same thing, where it's, if it's null, essentially the data in that column is still accurate. The one benefit of having an is active flag or something similar is that analysts have a clear understanding. This start effective date, end effective date with a null makes a lot of sense, I think, to data engineers. I think sometimes with analysts, unless they know, it can get very confusing. So I think the one reason I would sometimes add an is active flag is purely so that analysts kind of have a clear understanding that's like, oh, there's an is active flag, and it makes it obvious. Whatever you do pick, just be consistent, because again, if you've got 5 different tables, one is active, one uses this null fashion, another uses a different way, it's going to get confusing. So that's kind of what goes on in the staging. And that's, I want to go over that because that can be a little more complex. There's still some other things you might do. Again, some remodeling, some denormalization, maybe some renormalization if you're having to kind of take apart things and put them back together. But it's just kind of the messier section of work. So that's why I wanted to go over it a little more. All right, now there's still a ton of other things to consider when you build an ETL. And we talked about this with the different types of tools that you have. Whether it's no code, low code, coding framework, etc. There's just other components you need to think about. So for example, you need some sort of DataQA infrastructure. If you're just starting out, you're probably just going to build a ton of simple test cases, but especially as you start developing a more complex system, you're going to probably end up just developing a data QA infrastructure where you're tracking all your QA to make sure if things happen that are strange, you've got previous data that you can compare it to, etc. So it just, and also you can start abstracting QA checks to where, if you just want to implement some sort of consistent QA check across all your tables, it's very easy rather than having to build a new QA test for every table or every pipeline. So that will be eventually. Error handling and logging. This is very important. ETLs fail all the time. So, you need to be able to track why. Sometimes it's honestly nothing. Sometimes, especially once you start developing more complex ETLs that are running on more distributed systems, sometimes the server just for some reason kicks out or funks out and you just need to restart it. But you need to be able to know that something failed in order to do that. Logging is very important for maintenance. If something failed, oftentimes it'll be like a bad data row of some kind. Maybe sometimes one of the specific fields just was off or was a string when it was expecting a number. A lot of weird things can happen. You want to have logs that can kind of let you show, exactly what happened. Where it says field whatever, that where it was expecting a number, got a string on row 32. Having that clear conciseness is very helpful. Otherwise, you're going to be in a lot of pain whenever a problem happens and you're trying to debug where it happened. Similarly, dashboards for tracking. This is kind of be based off of your logging and error handling, but having some sort of visual tool is very helpful because you don't want people have to go through a bunch of logs through Vim and such. That works for some people, but not every BI and data engineer likes to use Vim, and having some sort of visual tool is very helpful. And this is why Airflow, I think, is very popular. Data lineage and data catalogs. Again, this is something that usually comes later, but it's very helpful, especially data lineage as you develop really complex pipelines. Instead of having to have someone go through the code manually and look through what depends on what depends on what depends on what, it can be very helpful just to say, hey, this field depends on this field, depends on this field, in kind of a map. A lot of tools these days do offer some sort of data lineage. It's something very helpful so you can kind of tell where some piece of data came from in the end. And then finally, some sort of metadatabase. And this will help track things like dependencies. What pipeline relies on what pipeline relies on what pipeline. You don't want to just have things running and not making sure that things run in a specific order. So having some sort of metadatabase to track dependencies is very important. All right, I did want to go over a little bit about DataQA, just because there's a ton of very simple QA checks that you might consider implementing, and I want to kind of go over what they are. So visually, I hope this helps. So categorical checks are basically typically when a field should only have very specific values. So for example, in the state field, we're really only expecting state abbreviations that are valid, state or territories. So it could be, Puerto Rico or something like that as well. So, Washington, that's valid, but WE is not a valid state. Technically, the application layer should catch this, but, I've definitely seen similar errors where, for some reason it's an open field and someone makes a typing error and now you've got a weird thing coming through. So checking for valid states or things like that makes a lot of sense. Another kind of concept is null checks. So null checks is kind of weird because it can depend on the field, right? So for example, with claim ID, the field is likely some sort of primary key in a different table, so there should be 0 nulls, right? 100% 0 nulls, that's just how it should be. Whereas, there might be a different field where, in this case, we've got state, where maybe you can have up to 20% null, right? For some reason. I think state doesn't make sense, but it's just an example. Sometimes some fields can be null, and it's not the end of the world. But how null depends. And so you generally have to figure out a range for that. And we're going to kind of go over some ideas on how you can do that in the next slide here, but that's what I mean when I say it's specific to each field. Some fields could be 95% null, and that makes sense. You might not want to bring it in if it's got 95%, no data, but there might be some value in it. I don't know. Other fields can be 5% null. Other fields can be 0% null, but it really depends on the field and what it's representing and how it's coming in from the application. All right, 2 other checks you can do are aggregate checks and anomaly checks. So aggregate checks, generally, I'll do between raw and production data. So just in case something happened weird in staging, you might need to do something like testing how many customers you had in raw versus how many customers you had in production. So it could just be as simple as counting distinct customer IDs And maybe, in raw you had 5, but now you've got 4. That doesn't make sense, right? Like you've likely lost a customer, and this could be something caused by some sort of weird logic. This check makes a lot of sense because, again, there's just so many chances for accidental removal of customers or data rows throughout your process, and you do need to check this. And it's just a good way of telling if something went wrong. Anomaly checks, in this case, the table I'm providing is more of for the system you might develop for anomaly checks, basically tests for data that doesn't make sense. So for example, in the first row, we have something called row count. It's just a row count check. So for this table, we're trying to check, hey, how many average values are we expecting for this data that we're currently inserting? And we're expecting somewhere in between 980 and 1020. We got 1000. So that's valid, right? Like we're going to call that valid. Whereas in the next row, the average value we got was 67, but this was out of the range, right? We're expecting somewhere between 92 and 89 for null percentage, and this was out of that range, so thus we are going to flag that. That's an anomaly. This is what I mean when I say, nulls depend on the field. And then price range, we're going to say it's not an anomaly because prices range between 60 and 120, and so this average value makes sense. So again, anomaly checks just are to check to make sure that the data values make sense. All right, so now let's kind of review what we've covered so far throughout all these videos. We've kind of talked about raw data, we've talked about ETLs, we've gone over data warehousing, so that was a few videos ago, but we're kind of going back to ETLs because we kind of just skipped over it. And so now we're gonna kind of go over after this, we've gotten from raw to ETLs to data warehouse. So now we're gonna start doing the analysis portion, right? Before going into more like metrics and dashboards. Next, we're gonna talk more about just the ad hoc analysis and data analysis process and how you should look at your data, analyze it, etc. So thank you so much for listening to this video. Hopefully it helps you kind of understand generally what goes on in ETL. And hopefully, as you're going forward, whether you're becoming a data engineer or a BI developer, this was helpful. If it was, please do like and subscribe. We're putting together some more content. So if you want to kind of sign up to get this content directly to you, rather than waiting for YouTube to tell you, there's some signups below. And with that, I will let you go on with the rest of your day. So thanks so much and have a great day. Bye.